Okay, 7.5 is a little bit like 7.4 in the sense, it's just a bunch of random stuff that it doesn't really fill enough time of a lesson to be its standalone own lesson. It's just, I'm calling this miscellaneous radicals. I don't know what the book calls it, but there's maybe like 10 different skills that we're going to try to hit today, all of which are kind of small and simple, but you just have to tune in and get your attention on there, because otherwise it'll get all just jumbled up in your brain. So one thing they're going to hit up in this lesson and in the homework is some problems have both roots and powers at the same time. So I'm here to tell you, you could do either one of those first. It doesn't matter what you do first. Which other recent lesson was like that? We had two options, and it didn't really matter which one.
Wasn't that the 7-3 one?
Yeah, 7-3. What do we do in 7-3?
It was either you could divide the roots.
We could divide first, or we could do the roots first. And it didn't truly matter, but we did decide it was easier if we could to divide first was our best bet. So today, again, it doesn't truly matter, and let's see if we decide we like something better. So somebody just yell, would you rather do the root first, or would you rather do the power first?
Power.
Do the power first. So if I leave the root for later, and I do the power, I get 64. Then I could try to cube root 64. 64 is on the cube root list in that table that I've made a few times. It is 4. That's a way to do that. You could also instead do the cube root first, but leave the power, because the cube root of 8 is 2, and 2 squared is 4. It doesn't really matter. They both got you 4. My personal opinion is do the root first if you can. Okay? If it's a choice, do the root first, I think, because when you do roots, the numbers have to get smaller. But if you do powers, the numbers get bigger. So does it matter? No. But I think if you can do the root, let's go ahead and do it. So next problem, similar style. Can you do the cube root of 27? Yeah, it makes 3. And then let's square it later to get up to 9. So if you can root it, let's just do that part. Question about that? Okay, for this one, can we do the square root of 6?
No.
No. So we're going to have to do the power first. The square root is going to just sit tight, and we would need to do 6 times 6 times 6 would make 216. Take y times y times y, y cubed. So that might be our first bit. Question about that? Then the question is, can we make that better? And the answer is usually yes. Let's do the power variable stuff first. What's the index here?
2.
2. How do we do this index exponent, King? Divide. 2 goes into 3 once, so out comes a y. In stays a y. How about 216? Who can help you with 216? 36 goes in 6. So because of the 36, out comes 6, but stuck inside the other 6. Question about that. Here's a better way to do that problem. Won't work every time, but it'll work. Yesterday we talked about root 7 times root 7 would just have to make 7. The root of 143 times the root of 143 just makes 143. So if we take a root of 6y times a root of 6y, that would just make 6y. And then there's a third root 6y that just sat there. We didn't necessarily need to work through that space. If you take a root cubed, that means the root times itself times itself. And the first two, the root times itself, makes a regular 6y. And then that third one, it just can hang there. That would be a quicker way to do that problem, although everything I said was true. I have no quick way to do this one. Cube root of 4, not a thing. If we have a cube root and we square it, that's not the kind of problem that we can utilize that trick. So I'm just gonna have to go with cube root and just do stuff. 4 squared, 16, x squared squared, 4, multiply powers there, y squared, and then we try to make that better. Can 16, cube root of 16, can we do anything with that?
Yeah.
8. 8 is on the cube list and goes in
2 times.
2 times. So out comes
A 4?
2.
a 2. Cube root of 8 would be down to 2. Stuck inside the other 2. 3, 4, can we do stuff with that?
Take an X out.
Take an x out,
Away.
leave an x in. How about 3 compared to 2?
You just put the y squared in.
Just, we're stuck. Y squared is too little to come out, just leave it be. Question about that, that's probably either the hardest or second hardest thing out of these skills. So if you're like, oh my goodness, there's 10 skills, is it gonna get harder every time? No, that's probably the most difficult of the skills, or top 2 at least, of what we're doing. Question about skill 1, roots versus powers. And we'll slide all the way to the left. This is probably the easiest skill of the day. So another way that roots can sometimes be written is as fraction powers. You'll see this a little bit through the algebras. You'll see this a lot if you get to calculus. Most root problems in the world of calculus get rewritten to have fraction powers instead. It's just a different way to write the same thing. So if I have an index of A and an exponent of B, I could write this as a fraction. It's just a matter of getting the A's and the B's in the right spots. Where the A and B go, it makes sense to me memory-wise and just experience-wise.
Is it B over A?
It is B over A. Why does it make sense in terms of appearance that the B would go to the top? It just looks right to me. Is there a reason why the B would go up? Yeah, when you write an exponent, you always write it up. Like, the exponents are always like in a lifted position. So you take the exponent, which lives in a lifted position sort of world normally, that's going to give you your top. So the index is just going to go on the bottom. That's just the way that those get written. So this, I can write x, fraction power, 3 over 2 or 2 over 3, it's the only option. It's 2 over 3. The exponent always is top, the index goes to the bottom. And then there's rules on what's where when, if it's invisible, they're still there. A thought on the fraction for that is 1/3. Because this has a 1 power that's invisible, that's 1/3. What's this one?
It's 1 over 2.
1 over 2. Because this still has the invisible 1 power and the invisible index 2 is there. This is the same concept, it's just with a number instead of a letter. Don't mess with the 8, just keep 8, 8, and just write fraction power. 5 over 4. This would just be a 17,
1 over
fraction
5.
power, 1 over 5, because there's an invisible 1 on that. Question about that group. I think that's like the easiest skill. Slide slightly right. This is the same skill, but we're going to need one extra little bit of something going on with this one. Anybody a thought on what I'm going to need in this one that I didn't need in the other one? Let's go fraction power first. What fraction power would we make?
1 over 6.
1 over 6. Who needs to still be around?
5. X.
Okay, if we just do that, we're wrong. Everything we did is right, but if we stop writing, we're wrong. No?
Are there 2 fractions?
No?
Let's go with bars.
No?
Don't they all have to be that power?
There's
They all
2
have to be to the power. Right now, who's the only thing going to that power?
Oh, the Y.
Only the y. Only the y is getting the power with it. How do we make the power go with everybody?
Put the 5x1 in parentheses.
What'd you say?
Parentheses.
Parentheses. We'll need parentheses around things. Under a radical sign, when you have multiple items, there's invisible parentheses there. You just need to make them visible when you get right fraction powers sometimes. Why didn't we need them here?
Because there's only one.
There's only one thing.
Yeah.
Okay, but here we have like 3 things under there to keep them all together to the power we need that.
What if it was like 5x squared y?
Then it would, if this had 5x squared y, this would still have 5x squared y. You could, as an alternative, you could go 5 to the 1/6, x to the 2/6, y to the 1/6. That's true, but like harder, I think. And what would we want to do to this one also, in fact?
Simplify.
You'd want to simplify that fraction if you could. But this, you could go individualized items, but I think it's easier to go parentheses, single item. Something there. Then, one of the great truths of most math lessons is whatever you can do, you can also
Do the opposite.
do the opposite and undo. So if I give you something like this with the fraction power, you should be able to get back to root town again. So this would have index of 3, because bottom is index.
A
squared.
A squared.
This would have index m and
AK.
a to the k. Alex Kirilov, AK. This we go,
27.
27 inside.
2 on
2,
top.
And then
3.
3. This one I go
ABC.
ABC.
3.
That's a messy 5.
Oh.
5. Yeah, we're done.
Question about that. Can you wait like 10 more minutes, or you gotta go? One of these they might want you to change, one of them might be okay. So if the directions just said, write it as a radical, they're all done. If the directions say simplify, simplify is a tricky set of math directions. Simplify basically means do everything you know how to do.
27.
This cube root 27 squared, what would maybe be a better answer if it said simplify? What did you say?
3 squared.
3 squared, which is 9. And I'm not going to belabor that point, we just did that a minute ago, 5 minutes ago. But cube root 27 squared, we did a minute ago, it was 9 over there, it still maybe is 9 over here if that's what they want to do. Question about that? This is about equivalent difficulty, I think, to what we did. Might even be easier because we've done this before. So negative powers mean something. They have meant something since an earlier chapter. They still mean the same thing. Does anybody remember what negative powers mean to do? Yeah. Turn into a fraction could work for me. Flip things work for me. If at present the negative power is on the top, it's going to move to the bottom. And if it's on the bottom, it's going to move to the top. If you don't see a fraction, it's because presently some of these are on top of 1. When we change these, when we flip these, they're no longer going to be negative powers. They're going to become positive power answers. So what's this going to look like?
1 over x to the third.
1 on top of x to the positive third. Started off negative power on top, it has to end up with a positive power on the bottom. This started with a negative power on the bottom, so we want instead,
5 over 1 to the 1/4, right?
you might have said too much stuff there.
Just 5 over 1/4.
Just 5 to the 1/4. If you wanted to write a fraction, this whole thing could be on top of 1, but that just makes it uglier than it needs to be. Negative power on the bottom becomes a positive power on the top. This somehow needs to have 4 to the half. Like the 4 to the negative half is going to turn into 4 to the positive half. What else changes around that?
Put a 1 on
One on
top.
top.
1 on top of it. This one, the negative 2/3 needs to change to a positive 2/3.
5 over
It is a
1.
5, because if we flip, 1/5 becomes 5. This answer needs to have a positive 2/3 power somehow. How are we going to manufacture that?
Just put a 1 on top.
Put a 1 on top of that whole thing, 3AB. So if it was on the top, put it on the bottom. If it was on the bottom, put it on the top. There's always invisible bottoms of 1, but we prefer not to write those. If the directions say write it without negative powers, we're done. Or if they say write them with positive powers, we're done. If the directions say to simplify, for sure one of these would adjust.
Is it the last one?
No, we could adjust the last one, but I think it would make it like worse.
The 4?
The 4 thing would. What did half power mean 2 columns ago? What was half power about?
Squaring. Yeah.
Squaring? Square rooting of 4.
1 over 2?
That would be 1 over 2. This would be a simpler answer than that. Half power means square root, and we could do that square root. There's nothing you can do with any of the rest of those. If you really wanted to, I guess, you could go 5 squared is 25. If we made that into a root, it would be a cube root. Personally, I would call that a tie. If you were on the test, that's a good answer. That's a good answer. Whose answer is better? Tie. I don't think either one is the least bit better than the other one. This is definitely better than this. That's definitely simpler because you made the root like disappear. That's good news. But like this, if you wanted to square that and then write it with a cube root symbol, if anything, I'd say that's worse. Like you're just making it bigger. That might even be worse. I'd toss up. I'll still say tie. Question about that concept? That's not new. That's old. Flipping with negative powers is old. Multiply is old. If we multiply and the bases are the same, do you remember what the ruling was on that?
We still straight across, right?
Do they just stay the same?
Do what?
Do they just stay threes?
It's going to stay 3s. Yes.
Use Adam. The power.
Add the powers. When we multiply things that have the same base, we're going to add the powers. So 3s times 3s make more 3s. Just add the powers up, 3/5. If I wanted to be meaner in fraction world, I could have made you make a common denominator and like do it, but I didn't choose to do that. Divide. If x's divide x's, you're still going to get x's. You don't ever change the base on that. You subtract the powers. This time I was a little meaner because you don't have a common denominator. So you'd have to make a common denominator.
1/4.
Close?
Negative 1/4.
Negative 1/4. Question about that? I would generally consider that to be done. Unless, if the direction said positive powers only, how would you turn that into a positive power
Put it
only
at
multiple?
1.
Put it under a 1. Or if the direction said, get your way back to radical world, how would you get this back to radical world? X and a little 4 index. To me, these answers are all tied unless the directions specifically said radical or specifically said positive power. I'd say tied. They're all good. Something there. Similar skill if you take powers and they go to more powers. You never change the base on any of these rules. What did we do to the powers on those? We multiplied the powers. So if we multiply those powers, there's your straight across from earlier. Somebody said straight across. This is a straight across kind of moment or a canceling kind of moment. Half. That's probably good. Unless the directions specifically say, I want a radical answer, what radical answer would this be?
3.
3.
And then 2.
That's it.
What if this said specifically, I want a radical answer? Index?
5.
5,
3.
3, 3. And you probably wouldn't want to write 3, 3. 3 to the third is 27. That would be probably a better answer. Again, these little changes I'm making, you only have to do that if the directions clearly say you have to do that. Question about any of this? I've got one more column to create and then we'll call it a day. Like I said, it's like 10 skills. No individual skill I don't think is like crazy hard. It's just a lot of information. So the last thing we're going to do is some simplifying Your best bet on most of these is going to be to make the fraction powers, somehow simplify those fractions, and then return back. So if I have 10th root x to the 4th, bunch of different things, some of which we've done before.
Suddenly I see.
I'm going to steal a little bit of space too back to my left. Didn't have quite enough height of my board. One more to squeeze. I don't know how to do it. So this, best way to do this is probably take that x, make a fraction power like we did on the leftmost column when we started coming across. This would be
2 over 5.
4/10 for a second, which would become
2 over 5.
2/5, which can become back to a root as
5
x
x
squared. That's all true. That's a little bit longer than maybe how I would do it now that I've done a few of these in my life, but everything I did there was good. Question about doing that? If we wanted to skip this work, you can do that. What might you notice that can be done on these? Divide them all by 2, like take out a GCF kind of thing. So if you notice that these can all be divided by the same number, and you just divide them by the same number, you're going to get where you want to go. So this, you could work through the fractions, okay? You could work through a to the 2/8, b to the 4/8 like we did. But if you want to do this in the shortest possible way, just find a number that goes into everybody
2
and just do it. 2 goes into all of that, so 4, 1,
2
2, and Pittsburgh. So we're good. This one we could have done a week ago. 2. There's some mixed into this homework set that are like the old ones we've been doing. The cube root of 8 from that table is 2. And what have we been doing with these for a while?
Subtracting.
Dividing. 3 into 6 went twice. 3 into 9 went 3. If this were a 10 and we had a remainder, what would you have had to do? Make the radical, leave some stuff in. This is unlike anything we've done. We did multiply some radicals, but the day we multiplied the radicals, the indexes had to be the same. And I told you if they weren't the same, you couldn't do it with the scary student word yet, meaning it's coming. Here it is. So if we're trying to multiply these, I'm going to go with my advice here. Make these fractions. The x is to the half. This x plus 5 is to the third. We're going to play around with those fractions. If we want to get these eventually back to the same kind of root, they need to have the same index, which means that these fractions should be forced to have a common denominator. What common denominator can you force these to have? 6. This one would be 3/6. This one would be 2/6. So if we get this written back, the index is 6. X is to the third. X plus 5 is squared. I'd be happy with that. It's possible in the homework they might want you to FOIL this out and then distribute other stuff. That's up to them. They wrote a book. They can do what they want. Question about doing that one. This, I continue to do that same advice. Make a fraction stuff out of it. X plus y, fraction power, 3/4. Bottom, x plus y, fraction power,
1/2.
1/2. How are you gonna manage this? We wanna subtract. This is a dividing problem like I just erased it over there. But this is a dividing problem which makes us wanna subtract the exponents. X plus y would be to the
-4.
close.
Oh, that's a 3 on top.
Yeah, 3 on top.
1/2.
No. 3/4 minus 1/2.
Oh, it's
It would be 1/4. This isn't a done answer. I was starting to circle that and change my mind. Why isn't this a done answer?
Can you like put it in a square root?
We gotta get back to square root form. Yeah, anytime we make those fractions and simplify, we have to return back to our radical life. So this radical would have index 4. We don't need the power of 1. Something about that. So one more time. This x, fraction power,
2/3.
2/3. This y, fraction power,
1/2.
This z, fraction power,
5/6.
5/6. For us to eventually return this to a single radical location, these fractions all need to be forced to have a
Six.
common denominator. Common denominator is 6. This is
4.
4/6. This one would be 3/6, and we got 5/6. So the index is 6. X,
4.
4, y,
3.
3, z,
5.
and then call it a day. Question about any of these, like bunch of random ideas that all just got jam-packed into one big day. So here's what's coming up for homework. This tonight homework, we're gonna skip the 3s. It's not quite as ridiculously long as yesterday when they wrote the book, but it does go to 66. But we're gonna skip the 3s, going up to 66. Tomorrow, this week, will be Thursday. Friday, I just gave you a sheet, so that sheet we do Friday, we do a review Friday, which means next week, Monday off for President's Day. Hooray for all the presidents, even if we don't like the presidents at certain times, at least we get a day off of school because it's once a year. So regardless of party affiliations, one day a year off of school for President's Day. Tuesday would be the quiz that covers like this week. Homework that we'd want to look at. Yesterday, a lot of people were absent, so we got scrambled. I did get quite a few 303s, but if people have questions on 303, I'd be happy to answer those. If you have a 303 that's as good as it's ever going to be, I would take it. But if you have some 303 we can make better, let's talk about it. Anybody have anything 303 that you'd want to talk about to try to make 303 better than what it had been? Okay, then the main new homework is 308, and I would have to think there's got to be some questions on 308 for people that worked the whole way through this, because this was rather long. But we did the 3s, but there were a lot of different skills, and especially when we got up there into the 80s, some of the questions were kind of big. Does anybody from the 308, did you run into anything that was like, uh-ohs?
The last, like, 2.
Last
Or
2?
Last 3.
Okay, so like starting around like 81?
Yeah, 81, 3.
So let me just do a quick, like, just reteach of the skill of how we did that. It wasn't like a problem with that particular one, it was just like the skill overall, like how to do it.
Kinda.
Okay. So if I say something like 7 is on top of 6 minus root 5. Okay, this is frowned upon. Why is this frowned upon?
It's not like possible.
It's possible, but it has a root on the bottom, and roots on the bottom are frowned upon. I can tell you why in a second. If we want to fix this, we fixed it by doing a multiplication. This is in parentheses. We're going to make some new parentheses. We're going to multiply the bottom by something, and we're going to match that multiplication on the top.
Same thing, but add a plus.
Same thing, but switch it to a plus. And this had a name. It was a C name. Conjugate. It's called the conjugate, it's just a fancy word that means switch the sign. So on top, I'm gonna multiply that same conjugate. What I had, sign, multiply the bottom, multiply the top. Are you with that? So if I go to multiply the top, that's easier. 7 times 6,
42.
42. 7 times root 5, even though that freaks people out. That's the,
7 to the root 5.
it's just 7 root 5. That's the easiest multiplication can be. You just write them side by side. Bottom, you'd have to think about foiling. And this is a negative mass. And this is a positive mass. But the good news is,
Cancel out.
those always even each other out. So the 6's would make
36.
36. Minus, these would make
5.
normal good old fashioned 5. And then a slight cleanup on the bottom. 36 minus 5 would be better as 31. You okay with that? If this had like 7 plus root 5, now you'd have a FOIL to do on the top. These would make 42s. These would make regular 5s. Those could go together. This would be 6 root 5. That would be 7 root 5. Those could go together. You might get yourself into a FOIL on some of those questions instead of a distribution. Is that okay on that skill? Yeah, that kicks in, that skill kicked in on 81. From 81 to the end, that's the skill you need. Anybody else on 308 run into like a single problem that was like, I don't know how to do this one? Or did you run into a section where you're like, I don't have the skill base to do this?
I haven't even looked at it yet, so
Okay.
when I get there, I'll let you know.
There's a video for it.
I'm gonna watch it.
Yeah.
I use 57.
57. So we're gonna just FOIL. So for 57, the root A times the root A would make a nice shortcut trick. We can just make that
That just be A.
regular old A. When root A multiplies root 3, make that the root of 3A. So when the root 2 multiplies to A, make that root of 2A. And when the root 2 multiplies to root 3, we'll get root 6. So it'll be 4 things adding up and nothing can really get improved. Just this, plus this, plus this, plus this, 4 of them. Is that okay?
Yeah.
Anybody else, 308, anything that got you hung up on what was supposed to happen with it?
We do 75 to
75. Yeah, that's a good question on 75. The cube roots are definitely harder to do than the square roots. What we're going to do for the cube roots is we're going to multiply the bottom by something. We're going to multiply the top by the same something. But we have to think through what that is. For square roots, there's no thought involved. If I have a square root here, what do I always multiply by? Like if this problem had square root of 6 on top of square root of 7. There's no thought at all about what to multiply this by. It's just square root of 7. We always take the root times itself. And in this case, that would just make us get
7.
regular old 7. For square roots, you don't have to think about it. Whatever root you have, multiply by that, the root will go away. You just have to play around with the top. For cube roots, we don't do that. We have to be a little bit clever about what we're doing. Because if we take 6 times 6, that's 36. The cube root of 36 is worse. That doesn't mean anything to us. So check our table of cubes. 2 becomes 8, 3 is 27, 4 is 64, 5 is 125, 6 is 216. We need to multiply to make one of those numbers happen. So can 6 turn into 8, 6 into 27? Like who can 6 turn into by us multiplying?
What?
Who does 6 go into, in other words?
216.
216. 6 could be turned into 216 if we multiply by 36. You with that? We'd like the 3 to divide into the power. 3 can't divide into the power. How many more powers do we need so that 3 can divide into the power? We need 2 more. If we do 2 more, we'd be up to 6. So I have to do that on the top. So top, 2 times 36,
72.
72. We'd have a y to the 4. We'd have that x squared. We'd sit there as an in-between step. Are you with those jumps so far?
Yeah.
And then let's just try to upgrade. We created this bottom because we can do it. The cube root of 216 is 6. 3 can divide into 6 twice, and there's no more root on the bottom. That's where we're trying to get. You with that?
Yeah.
Then on the top, we can do some stuff about some things on the top. Can the x squared be upgraded?
Nope.
No, it's too little compared to the 3. So leave that alone. Can the y's be switched around a little bit?
Yeah.
Yeah, how?
Take one out, leave one in.
1 out, 1 in. 3 into 4, 1 out, 1 in. Does 72 have any friends on this list?
8, baby.
8. 8's gonna go with
8.
9. So stuck inside,
That's what I meant.
You leave the 9 in?
leave the 9. The cube root of 8 is special and
Two.
changes into the 2. And then we're almost done.
You can
You with all that still?
Yeah.
Yeah. What's your last little change?
turn it into a third.
Yeah, 2 compared to 6. 2 can interact with 6 to just leave us a 3. That's the best possible thing we can get out of 75. With that? That was a good question. That was easily the hardest one out of the like 65 to 78 group where you were doing those. Cube roots are mean. Cube roots, you have to think about who you want to multiply to make the bottom like the way it needs to be.
I got 11.
I'm sorry.
Anybody else 308, any kind of anything about how to improve our homework lives? So again, one more time, tomorrow we've got this 3:15 due. Then for Friday, we have sheet due. We go on weekend, we come back, quiz will be next week. Grade period ends in a 6-day countdown, not this Friday, but the next Friday is grade period, end of the line. We have 2 more days this week and 4 days next week, 6 more days.
I did.
I think some people were in the bathroom. If you have your 303s that are as great as they'll ever be, send them. And then 315s, if you did those and they're as great as they're gonna be, send them. If you have things you're working on, I guess keep those. That's probably a wrap.